Okay, well, let's look at number 3. And that answer key should say we need a 4th degree polynomial, but it's on the 5th term where the error is. Okay, so estimate the value of e to the 1.5 using a Taylor polynomial centered at x equals 2. That's important. Find the least degree of the polynomial needed to have the least degree of the polynomial. There's where my mistake comes from on the answer key. Needed to have an error less than 0.001. Okay, so if we're centering at x equals 2, then e to the x becomes the sum from n equals 0 to infinity of x minus 2 to the n over n factorial. Okay? So there's that polynomial. That's what it looks like. If we were to expand this, so if we let n equal 0, we'd have x minus 2 to the 0 power, which is just 1, over 1 factorial, or 0 factorial, which is everybody's favorite, is 1. Plus, if we let n equal 1, we get x minus 2 to the first power over 1 factorial, and we can keep going. So this would be x minus 2 squared over 2 factorial plus x minus 3 to the third over 3 factorial. You get the idea, right? If we're going to do this problem, this would be the type of problem that would be on a calculator section. Why does that say 3? X minus 2 to the third, x minus 2 to the fourth. Apparently changing numbers is killing me here today. Okay. This would be my polynomial. This is the polynomial that is e to the x centered at x minus 2. So if I'm going to figure out e to the 1.5 that has an error, then this polynomial becomes e to the 1.5, which then means it's the sum from 0 to infinity of 1.5 minus 2 to the n power over n factorial. Which when we substitute this in, well, that term's 1, then I would have 1.5 minus 2 to the first over 1 factorial, which would be plus negative 0.5, right? Mm-hmm. Plus 0.5 squared, that one will end up positive. So this would end up being, if you type it in your calculator, you end up with 0.125. Plus, if I keep going, if I plug in 1.5 minus 2 to the third, we end up again with a negative number. So this would be negative 0.02083. I'm going off of what I have written. So if you got a different number, let me know. If I plug in 1.5 again to the fourth term, I end up with 0.0026 positive. And if I end up with the third term, I end up with negative 0.00026. Okay, the problem here is that 0.0026 is not less than 0.001. So right here we're close, but not quite, right? So that's not quite less than. And so it's on this term. This is the term where it's less than. So my remainder happens on that fifth term, which means that the polynomial I want, we need a fourth degree polynomial, so that the error, which happens on the fifth term, is less than 0.001. Oh. That's one way to do it. I can show you another way if you want to see a different way. Anybody want to see a different way? No. That was a pretty hard no.
Maybe I just didn't see the negatives for some reason.
There may not be on there. Here's why they may not have been put on there. Because I know when we're dealing with remainder remembers always the absolute value.
Yeah.
And so since it's always the absolute value, sometimes I get lazy.
Okay. Makes more sense. I was just panicked and like, oh my gosh, am I not doing the math right?
No, you're fine.
stuff with the tests from last chapter?
Only in the sense that it may ask you, and no, not a lot. I'm trying to think.
Okay.
We've had a couple with the test from last chapter.
Like the root.
Yeah.
Ratio.
The-
Should be it.
Yep.